SolidWorks Simulation offers advanced nonlinear analysis capabilities that allow for the analysis of plastic deformation. To illustrate this capability, we will run an analysis with linear deformation and view the results. Then we will compare the results to a nonlinear analysis. Working with sheet metal parts in SolidWorks Simulation is easy. By using familiar SolidWorks selection methods, we can quickly gather the required faces to define our shell elements, and then enter the material thickness. By default, SolidWorks Simulation uses the material you have already defined in your SolidWorks model, as you can see here. First, we must define how this part is restrained in the assembly it belongs to. You can do this by simply clicking on the face. To apply the load, we select the face that gets pushed. Since the face is round, we will use a reference plane for the direction of the force, and then specify the magnitude of the force. Now we can mesh and run the analysis. Let's have a look at the displacement plot, and we will show the true scale. You can easily see that the part deflects by a significant amount. Because this part will probably suffer plastic deformation, the linear analysis result may no longer be applicable. We will run the same test over again, this time using a nonlinear analysis. With SolidWorks Simulation, you can simply copy the shells, loads, and restraints, saving time and ensuring consistency. With SolidWorks Simulation, we can easily modify the load condition so it varies over time using the curve option. In this example, we will create a simple curve that represents the load applied. This will allow you to see the deflection after the load is released from the model. In this case, we must define a custom material and specify the tangent modulus that is not given in the default material properties. Now, let's run the analysis. Here, we get significantly different results. First, we will show the part at maximum deflection, and then show it again with no load applied. Notice that the part has not returned to its straight position. Therefore, it has been plastically deformed. This deflection is obviously too much. However, we need to design the part for the applied load, so let's try some other ideas in a new study. We will copy the nonlinear study and change the thickness of the part by just modifying the thickness of the shell. In addition, we will change the material to one from the library, perhaps one that will be stiffer. Now we can run the new analysis. With this new design, we can see from the second displacement plot that the final deformation is half as much as the old design. With SolidWorks Simulation Nonlinear Design, you can solve complex problems in your part design in minutes. This allows you to come up with the optimal solution, while saving time and money.